Next, we want to discuss the accessory structures that are connected to your integumentary system, your hair, your nails, and your glands. And I'm going to go through this a little quickly just because, these are not as important. The glands are kind of important, but the hair and the nails, not as much. So here we go. All right, so we have the hair, which is an accessory structure. Everybody knows what hair is. I have a beard. I used to have more hair on top of my head, but currently that is not the case. But it's one of the accessory structures or appendages of the integumentary system. Hair, nails, glands, derived from the epithelium, dermis and epidermis only, and assist in the overall function of the system. Hair, pili, is the name for it. Small filamentous structure protrudes from the surface of skin over entire body, except, remember we talked about regions of thick skin, also doesn't come from lips and parts of the external genitalia. And this is the basic structure of hair. See the cuticle on the outside, cortex, and then the medulla in the middle. You'll see that see how it has its base sort of in the dermis and then protrudes through the epidermis, has its own little blood supply here. You have cells that are active and growing out. Hair does not have a significant role in human beings. There are people who think that it used to have a significant role, but it currently has no significant role. Your hair you don't have enough hair to really keep you warm. Even if you let your hair grow all over your body, you didn't shave any part of your body, it still wouldn't be really enough to keep you warm, but it does provide some protection. We have eyelashes that protect things from entering our eyes. We have nose hairs that protect things from entering our nose. If you have hair on your head, it's protecting the scalp from UV radiation. All right, what is the structure of hair? Two main parts. You have a shaft and a root, which are both stratified, squamous, keratinized epithelial cells, very similar to the cells in your epidermis, which are they're in various stages of development. All right, the shaft is the portion protruding from the skin surface, and those cells have already been completely keratinized. So just like the top layer of skin, stratum corneum, the hair those cells are already completely dead. They've been completely filled with keratin. They're hard and dead. If if I squeeze my hair a piece of hair as hard as I can, it does not hurt. The root, the other part of the hair is the root, and that's the part that is under the skin, embedded in the dermis. We know it's surrounded by a sensory neuron. We have the root and the hair papilla, collectively known as the hair bulb. This part down here. Many epithelial cells in the root are still alive. They have not completed the keratinization process, very similar to skin. You have the cells that are alive at the bottom, near the blood supply, and then cells grow out to the outside. This is the basic structure of the hair. You have this what we call matrix, small number of keratinocytes at the base of the root actively divide. That means they go through mitosis. Root is embedded in hair follicle, enfolding of epidermis, extends deep into the dermis or even the hypodermis. And then basically you have, like I said, it has a blood supply here, and these cells are continually to grow out just like the epidermis does in your skin, and it produces this hair. This is the general structure. You don't have to memorize this. You have the cuticle on the outside, cortex and medulla. Medulla is your soft core, middle cortex, hard keratin provides strength, and an outer cuticle provides mechanical strength. You also have these erector pili muscles Um, Small bands of smooth muscle attached to the dermal root sheath on one end and dermal papillae layer on other, connect the sort of anchor the hair. But contraction of this pili muscle gives you what we call goosebumps. So it's a little muscle associated there. It helps support down here in the dermal root sheath, helps support the follicle. The growth of hair, very simply, mitosis occurs in the matrix, the deeper and the deeper side of it. Cells divide, push cells above them further away from the blood supply. They keratinize and die, very similar to skin. You do have what we call a resting stage, where they have the cells are are in a resting stage. Mitosis in the matrix ends as the cells die. Hair is pushed toward the surface where it remains dormant for a month or two. So in this case, you do have, there's a growth time and there's a resting time. So it's not always growing. Okay. Just some interesting things to note about hair. Like I said, not very important. Hair doesn't really have much purpose and as far as anatomy and physiology is concerned at this point. Nails have a little bit more purpose. Very similar, stratified squamous epithelium filled with a hard keratin. Nails have nail body and a nail root that make up the nail plate. This is the shape of your nail. The idea of, I say it on this side, the idea of the nails is basically to protect this very sensitive area known as your fingertips. Your fingers, you hold things, you touch things, so that they believe the idea is just to protect a very useful area of your hand, so to speak. So this is the basic structure. I don't need you to know all of this as far as the nails are concerned, but just, look at the diagram. You can see the basic structure of the nail. Nail growth occurs in what we call the nail matrix. As you can see here, toward back in here is your nail matrix right there. Same idea as hair, same idea as skin. Dividing cells push neighboring cells distally. So the growth is here and it pushes those cells out. They die once keratinization is complete and have been cut off from the blood supply. Grow an average of 0.5 millimeters per week, and your toenails do grow more slowly. I think somebody mentioned that they knew that. It's always nice to get your manicure and pedicures done. Nails do not contain melanocytes. Right, so they're mostly, that's why they're translucent. And that has some benefits because you can see, there are some things you can tell by looking at your nails. Its primary function is protection of underlying tissue. So protecting those fingertips and those toe tips, right, from trauma. We know that the edge of these fingers touch everything and we need them. So they need to be protected. Now we're going to get into the glands. Now these are a little more important than your hair and your nails. You have two basic types of glands. Sweat, sudiferous glands produce sweat, and sebaceous glands produce this oily sebum. Right. These are the basic structures. We've talked about the eccrine, apocrine a little bit. So you have eccrine sweat glands, apocrine sweat glands, sebaceous glands. Right. 4 types. You actually have 4 types of sweat glands, and they differ structurally and in the product secreted, but they all secrete by exocytosis. Remember, exocytosis, vesicles going towards the surface and then releasing the contents of the vesicle out of the cell. right? So we have the eccrine, which is the most prevalent type. There's 4 types. Simple, coiled, tubular gland. We have sweat. Sweat contains mostly water, waste products, and electrolytes. You do have waste products in sweat. That's why it has a little bit of a smell to it. Mostly water. Exits from the sweat pore onto the epidermal surface. This is your basic sweat gland, meant to cool you off. Right? Right, that's your eccrine sweat gland, releasing sweat by exocytosis. You have the apocrine sweat gland, found in specific regions, axilla, anal area. Large glands release a protein-rich secretion into the hair follicle. Secretions become odoriferous. Once skin bacteria metabolize the contents, and these we see are influenced by sex hormones, become active after puberty, apocrine glands. Right, so that's near the hair follicles. Right. We have ceruminous glands, modified apocrine glands, release a thick secretion called cerumen, which is earwax. Everybody knows you have earwax. It's something that we have to periodically clean. It releases it into the hair follicles in the ear. Right, that's considered a type of sweat gland, earwax. It does have an importance. It's not there just to as the apocrine and the eccrine, release their substances primarily to cool us off. But this cerumen earwax is to trap, sort of similar to when we talk about mucus in our airways. It's there for a purpose. The mucus in our airways is there to trap debris coming that we might breathe in. The cerumen in the earwax is there to trap things that may try to come in through our ears. And then we also have mammary glands. Now you may say to yourself, mammary glands, sweat glands? Yes, and I think I mentioned this before, but if not, I'm mentioning it now. Mammary glands are actually a highly specialized sweat gland, producing a modified kind of sweat. And I know this you don't think of earwax as sweat, but it's the same type of gland, but it produces, instead of producing what we think of as sweat, it produces milk, which is a modified substance. We also have sebaceous glands. Let me just move this. Branched with clusters of secretory cells surrounded by small ducts, acini. So you have sections, clusters of cells going into one duct, form a central duct, empties into the hair follicle or a small pore, and they make sebum. They're everywhere on the body except for your palms and the bottoms of your feet, because that's where you have thick skin. The greatest number is on your face. That's just why people get, pimples and stuff. Secretion is influenced by sex hormones, especially testosterone, and dramatic increase after puberty. You remember after puberty, your skin didn't look as pretty. That's how we kind of how we know somebody's going through that. Some of you may have recently come out of that. Sebum is waxy, oily mixture of mostly lipids released by the holocrine secretion. So the holocrine is different from exocytosis. Exocytosis, you're releasing a vesicle to the surface, and it's releasing its contents out of the cell. Holocrine secretion, the secretory cell accumulates, the actual cell fills up with the sebum, and then the whole cell bursts and the sebum is released that way. So a little bit different release. right? It's important for this last point, inhibits growth or kills certain bacteria, the sebum does. And that's your sebaceous glands releasing sebum. All right, we're going to go right into pathology of the skin. We already mentioned acne. 96% of adolescents experience acne. Accumulation of sebum, which we just talked about, and dead cells within sebaceous glands produces what we call a blackhead. All right, that's basically acne. It can become severe and cause scarring. The primary cause of acne is, increased testosterone, causing, more sebum to be released. Okay. You also have wounds that can happen in your skin, lacerations, burns, skin cancer, all common things that can happen in skin. All right, burns are very important. I know I actually have somebody who, a client of mine who is a emergency, I guess he's an emergency nurse. He's the guy that flies in on the helicopter. It's kind of cool stuff. But he was just telling me how this was out in like central PA. He had to like fly in, and there was an apartment fire, and somebody needed to be helicoptered. They helicoptered them from like around York, PA. They helicoptered them to Baltimore, actually. So it can be a serious thing when you experience, obviously, a fire. Everybody knows fire burns, and it can cause some issues. And so burns can happen by fire, heat. It can also happen by extreme cold, a freezer burn, electricity, chemicals, radiation can cause burns. We separate burns based on degrees, right? So we have first degree, superficial. Remember your layers of skin. Remember epidermis, most superficial layer of skin. Then you have, which is made up of 4 to 5 different layers, but epidermis, and then we have the dermis, the connective tissue layer, and then we also have the hypodermis, or subcutaneous fat. That's what it's called. Okay, so if you have a burn just on the top layer of skin, this is probably most burns. This is, you touch something hot, it's considered first degree, only damaging the epidermis. So it's only damaging your top layer of skin. You can have some redness, some pain, but you won't have permanent damage. Remember, a lot of those cells are already dead, all right? So they're being replaced anyway. Second degree burn involves the epidermis in part or all of the dermis, right? So this is, you've burned through the epidermis, and you've also engaged the dermis beneath the epidermis. This can result in pain, blistering. This can result in a scar, because you could potentially destroy cells, destroy some of your keratinocytes, and therefore you could have like a permanent scar here. And then third degree burn, I know this looks pretty disgusting, but third degree burn is a full burn, a full thickness burn. So you've burned through your epidermis, your dermis, all the way down to your hypodermis, your subcutaneous fat, or deeper. So if you get down to the hypodermis or the muscle, the bone, that's not good. Now, the interesting fact about this is that it's not painful at first. And you may say, why was that? Why is that? Because you've burned your nerve supply. Because you've burned so deep, you've burned the nerves. Therefore, you have it's like no sensation. It'll feel like numb, so to speak. And that's not good. there's a lot of issues with third-degree burns, um, because your protection is taken away, right? You have no epidermis, no dermis, so you have no protection. So you can, your body can lose fluid. You can, it can, it you know, depending on how many third-degree burns you have, how much it covers the body, you can, your temperature control can be off. Um, you can go into shock. There's a lot of issues. All right, that's more on the third degree burn. Talked about dehydration. You can have massive fluid loss as well, and infection is very high as well. This is kind of like the rule of nines. This is something in case, and if you are going into some kind of emergency nursing or anything, they basically divide your body up into sections, and this is how they decide when they say like they had, you know, 63% of their body burned. You may say, well, dang, how did they figure that out? Well, if you have burns on, so they count each leg is 9%. So if you burn both legs, that's 18%. Each arm is 4.5%. So if you burn both arms, that's 9%. The middle torso, the front, the anterior is 18%. And your head is 4.5%. And so that's how we get the percentages of the different parts of your body that have been covered by burns. So that's when you hear the, they burn 27% of their body, that's what they're talking about. This is how they get those numbers. Skin cancer is also, we talked about there's lacerations, there's burns, there's acne, there's also skin cancer. And this can be very detrimental, of course. Everybody's probably at least, well, I don't know, not say everybody, but you've probably all, I know you all have heard of cancer. Maybe you've heard, maybe you know somebody who's had cancer, have experienced it. This would be a great time to, ask people to tell their stories if they have a story. And I'm sure, out of a class of 24 people, at least, 4 or 5 people know somebody or have experienced it. I have experienced knowing somebody with that has struggled with cancer, and skin cancer is one of the most common ones, which is caused by mutations in your DNA. Remember, those mutations can come from, UV exposure. Sun is a good thing. I love being out in the sun, but you have to remember that it can be detrimental. Right, so you can have mutations in your DNA, induce the cell to lose control of the cell cycle. Unchecked cell division leads to the formation of a large population of undifferentiated cells, which is a tumor. So the cells are just dividing, but they're not actually becoming skin cells. They're just like undifferentiated cells, and they, just have a mass of cells just that are continuing to grow. That's what we call a tumor. And then what is really bad is when it metastasizes. Tumorous cells with cells that their DNA is mutated, they're just dividing uncontrollably, get into your bloodstream or your lymphatic system and spread to other parts of your body. They travel through your blood or your lymphatic system to other parts of your body. And then once these cells like enter different organs and things like that, they can cause your body to basically shut down. Cancer is bad. 3 cancers that affect the skin, which all are linked to UV radiation. You also have other factors, toxins, other forms of radiation that can also cause cancer. We want to talk about the different types of skin cancer, right? So we have basal, remember stratum basal cell carcinoma. Most common type arises from the keratinocytes in the stratum basal. Right, so this is skin that has just been exposed to UV radiation, and you can have some in those stratum basal. Remember, those cells are mitotically and metabolically very active, so they're already growing a lot. If one of them The DNA mutates. They can cause cancer, and those are cells that would normally are close to a blood supply and are close to a blood supply, so they have the nutrients to grow, but they rarely metastasize. This can be surgically removed. I think literally they go in and just cut out this piece of skin. All right. You have squamous cell carcinoma, second most common. Cancer of the keratinocytes of your stratum spinosum, right? Stratum spinosum is just superficial to the stratum basal, right? This is squamous cell carcinoma. They can surgically remove this as well. Just basically cut it out. And then we also have malignant melanoma. This is a bad one. Early detection of melanoma is critical. Remember, the melanocytes, the cells that produce melanin, are connected to other cells. Remember, they have those sort of tentacles. They're sort of shaped like an octopus tentacles. That's not good if they are cancerous, right? So they can easily spread their cancer to other cells and also have easy access to spreading their cancer to blood vessels, right? So when you have cancer of the melanocytes, that is not good because it does have the tendency to metastasize, to spread, and it can be very dangerous to your health. This is a picture of your malignant melanoma. Okay. All right.